So we're going to go over this project in AWS Lambda here, which is in this URL, GitHub, Noah Gift, AWS Lambda. And inside of here, this is the thing that we're going to build. And really what's powerful about it is that I don't have to provision any servers. I don't have to control anything. I don't have to, install software. Mostly, this timer here will trigger a Lambda that will pull things, will read things from Dynamo DB. It will put some data that we pull from the serverless database into SQS. And then what's nice about this system here is that the Lambda will be called automatically every time a message is inside of SQS. So that's really one of the more powerful things about a serverless data pipeline is that it can actually directly create something, basically invoke a Lambda function when a message is put into this queue. What'll happen is that then this thing will call a natural language processing API. This is an API called AWS Comprehend, and then it will do some kind of a sentiment analysis and then put that into an S3 bucket. So what I can do first here is just show you, if I go to the console, a couple things, like, for example, how the comprehend system works. So I'm going to go to here, and I will go to put in an auth code. And if you haven't had a chance to play with this yet, the comprehend service is pretty cool because you can use it essentially to get natural language processing without having to build some kind of model yourself. So, if we just take here this default text Amazon, it's basically a blurb about Amazon here. We analyze it. You can see that it is able to extract entities. So it finds out the different, locations. It also can find out key phrases. So you can grab key phrases out, and then also will detect the language, and it will do the sentiment. So we can see that the sentiment is neutral, right? Because it's a 99% confidence. So basically, I don't have to do anything. I don't have to train some model. I just call this API. And that's why this fits really well with this kind of an architecture, is that if somebody's going to hire you as a consultant, or they're hiring you as a data scientist to work at a company, they may not even care what it is you use, right? Do they really care whether you created your own natural language processing library, or whether train your own model, or do they just care, did you solve my problem? So in the case of where I had a consulting client and they wanted me to do sentiment analysis around police community interactions, they don't care what I use. They just want it done, and they want it done quickly, and they want it to be reliable. So that's why I think, sure. The code, I'll show you in this example here. We will go to serverless sentiment analysis. The code itself to talk to it is really simple. It's just 2 lines of code, just like that. So basically, yeah. So inside of this repo, there's code that shows you how to do it. In fact, what we can do to start out with is, it's a good question you ask, is if I go here and I go to Cloud9, this is a great place to actually play around with some of the services. So let's just take something I've got set up. I have a ton of these. I don't know. Here we go, Docker build. And what I like about using Cloud9 is that it already solves the problem of security keys and all kinds of other issues. And in this case, what I can do is I can just cut and paste bits of code and play around with it. So I guess if I was really lazy, what I could do is I could go to this repo here and just clone it real quick. So I'm going to go to Cloud9, say git clone. There we go. And then I can go into this repo, and you see that the example source here was where that was. And I can look inside of this and just, I think it was this one. So I can source, I think I have a virtual environment here somewhere. Let's look real quick. Let's see, do I have the virtual environment set up somewhere? But if, I don't know if I can find one. SageMaker Fun, maybe that was the one I set up, SageMaker. But I'll just make another one just to make it easier here. So I will say Python 3 dash mvenv, and we'll say comprehend. I'll source that. There we go. And then if I do a pip, let's see which pip, that looks like it's in there. So we'll say pip install IPython. So I like to use IPython when I'm testing out one of these interactive APIs. And I guess I could just do this to make it easier. Okay, that looks good. So from here, I can now do IPython and play around with this. So type in IPython, and then I can go back to this code here and just essentially just grab, use this as an example. So I can say import Boto3. Okay, so Boto is not installed. We'll just install that. We'll say pip install Boto3. There we go. And then now I can do IPython again. And so Boto3 is a library for interacting with AWS. So that's basically the main Python library that allows you to make API calls. So anything you do on AWS will be done with Boto3 with Python. So the first you import it, like I just showed you, and then to make an instance of it, you just put in the name of the service. So this could be comprehend, it could be S3, it could be Lambda, it could be SageMaker, it could be whatever service. And that's what's nice about it, is pretty simple. So look, if we do this, let's just go like this. And then now I can just put some text in here. We'll just make some text and say, whoa, let's make this go up a little bit here. Let me just make this a little bit bigger. There we go. So for the text, I'll put this is a bad day for the NBA. There we go. And then I can go here and I can put in payload, right? And so again, all it is, I'm just putting this, and I'll change this to text. I'm just putting this string inside of here. That's it. And then now that I've got that instance set up from comprehend, security token is expired. That does not make sense to me when calling. That's weird. Well, in theory, that should have worked. I'm kind of surprised why that didn't work. Let me make an instance again here and see if I can fix this. And then, I misspelled comprehend. Huh. Yeah, I'm not sure why that's, I'd have to debug this and figure out why that's not working. That's very strange to me. That's not working. Maybe I did something in this particular environment, but in general, that's all you need to do. I don't know why it's not working right now, but it's the same as this. But basically, it's just one line of code. So that's what I typically do. Again, I don't know why that one's having a problem. Where if I wanted to play around with something, I would often, start with one of these environments. But let's do this. Let's actually, because I was going to do this anyway. Let's start from, let's build this system out, and let's just build a brand new brand new Cloud9 environment, because maybe that's part of the issue. So I'll go here. Sure. It is re-recorded. Yeah, 100%. Yeah. Okay. Okay, so the new environment here, we'll just call this serverless video or serverless Lambda. There we go. And we'll just leave everything by default. Yeah, really not sure why that had an issue. That shouldn't be the case. What I'll do is I'll be able, maybe that's just such an old environment, something weird happened to it, but I guess I can really quickly figure out whether we're going to have a problem because I think there's an AWS Boto3 command line tool, AWS, or I'm sorry, S3 comprehend command line. Let's do that. And let's just get that out of the way quick and make sure we can do that. So we can say detect sentiment. No, we don't want batch sentiment. We just want a string. And here we go. This might be it. Here we go, comprehend. But there should be, okay, let's see if they can show us a command line example here. Okay, this is looking good. There we go. That's what I wanted. That's what I want. So let's detect language. I think this is good enough. So so this is a pretty good guide. I'll put this into Slack here. But let's just grab this one. Let's just keep it. We can swap this out. But this in theory should be one of the advantages of this environment here. So if I go up here and I put in AWS comprehend detect dominant language, does that work? It should. Oh, what it's doing right now. Very weird. I'm not. Maybe there's an issue right now with that. Yeah, that's very strange. I've not had this problem. Maybe AWS has an issue right now with their comprehend service. Not. I'm sorry. Yes, the Corona. Something weird. I've not had this issue. If I type in AWS S3 LS, for example, that works. So yeah, maybe their comprehend service is having some kind of an issue right now. We'll solve that problem when we get to it. So what I'll do again, which I normally do, is I'll go to set up the SSH keys so that this particular environment I can check code in back and forth. So let's just do that real quick. SSH keygen, and then let's paste this and put this into GitHub. Here we go. And let's go to our GitHub account here. Okay, comprehend. Yeah, I think there's a way you can ask AWS what services are down as well, which I think we can do this. We say AWS services status, AWS services status. Here we go. Let's see what's up and what's down here. Weird. That's very strange. They don't show that comprehend has got an issue. Very strange. I've not had this problem yet. Well, and look, if I run it, it looks like it's working, right? So if I said this is a bad day for the MBA, yeah, so it figured it out, and it figures out that sentiment is negative sentiment. So yeah, not sure. We'll sort that out later. So got that plugged in. I'll go ahead and check in this or pull this code out so I can have it handy in case I need it. Let's go back here, clone this. So let's see if this works. Okay, good. So really the first thing to do here in this architecture that we're, maybe I'll just keep this picture up. I'll make a picture of this here that we can refer to. Is that we need to wire up a Lambda function here that will pull some data from Dynamo DB and then be triggered on a timer. So to do that, what I'm going to do is I'm going to look at this this notebook here, which should have a bunch of stuff in it. And I believe the first thing I'm going to do is create a Lambda inside of here that using our service, using the wizard here. So I'll go through here and I'll go to AWS resources. I'll click on this button here and we'll just call this producer, and we'll put today's date or something like that. Producer March 21. Okay. Next up, I will select a Python runtime. And for trigger, I don't need any triggers. This would be whether I wanted to call it as a web service or not. This is going to be completely end-to-end pipeline that doesn't require a web interface. So that looks good. For this, though, I would want to have a role here. So let me just show this real quick. If I go to IAM, with IAM, you do need to have a role that can access other parts of AWS. Again, this is kind of like the key card concept. So what I'll do is I will go to roles and I'll create a role and we'll call this one an AWS service. And the common use case would be Lambda. Allow Lambda to call AWS services on our behalf. We'll click this and then I will create a policy. And this policy will be that we want it to be a admin. Wait a second, actually we want, let's see here. No, we don't need to create a policy. We're just gonna use a policy that's already been created. So this one basically can do everything we want. So for prototyping, a lot of times just creating one that can do everything is easier. And then later using, let's say something like Terraform, you could provision the role and have it specifically only get access to Dynamo DB or S3 or whatever it is you're going to access. So when I'm prototyping, I typically use this one, administrator. And then just go through here again. We'll call this admin Lambda, and then we'll put today's date like that. There we go. Allows Lambda to call AWS services on our behalf. There we go. And now I can go back to here and I can choose a role, and we should be able to see admin. I might have to go back here and let's see here. Admin, what did we call that thing? We called it admin dev for Lambda. So let's see if we can find that admin dev for, yeah, no, admin. I might have to go, I'm gonna just start this over just in case it can't remember this. So again, we'll call this producer March 21. And we'll go to Python 3, go here. And then we'll select choose an existing, and it should be, yeah, here we go. Here. So sometimes if you create the Lambda, the role beforehand, it won't populate. So you may have to come back in here to find it. So now we found this thing. And to the first thing that we're going to do here is we're going to have this thing pull code from a database. So what we're going to do is, let's see if we can find this thing. let's go to, we want to create a timed Lambda here. And that would be, so that, let's just look at this architecture so I don't get confused. So we're basically, we want something that can read a list of company names here from Dynamo DB, and then it'll put these names into SQS and it'll run at a timer. So I believe I have this code right here that does all that. So I'm just going to copy and paste this code here, and then I'll explain what this does. So I'm going to go to this, and I will just paste this in here. And so let's just walk through what this does. So it's going to use Boto3, it's going to use JSON, and you can see again how Boto3 works is any resource you need to talk to, you just make a like a variable for it and then define the resource. I also do another one for SQS, and I believe I might have shown what SQS did before, but if not, let me just show you real quick how SQS works. What SQS does is, if you go through here, it basically, you just put things into a queue, and we'll just call this test right now. And basically, it allows you to put an infinite amount of data and read and write at an infinite scale. So basically, it's a system that can take more scale than you can ever give it, and it will just route messages around AWS. So it's like a building block for doing things in the cloud. And so if I want to test this out, I could go through here and I could say send a message and say hello, and then this message will populate inside of here, and then hello again, like that. And if you see how this works, that if I refresh this, there'll be two messages available. There we go. So two messages available. And then if I want to read it, I can say view the messages, start pulling, and you can see the two messages here. So basically, it's a way of just routing things all over the place. And you can tell Lambda functions as soon as a message populates in there, you don't even have to write the code to pull it or anything. It'll automatically fire off a Lambda message. So what I'm going to do here next here is I'm going to just delete this just because I was showing that how that worked for what we're doing, but I'm going to create one called producer, and we're going to populate this up with work. So I'll say producer. Okay, that looks good. And then let's go again to our code here, which, where is it? This one, yeah. So we need to have a table called Fang. So for this would be like Facebook, Amazon, Netflix, Google, like names of companies. So I'm also going to open up Dynamo DB, and I'm going to create a table if it doesn't exist. I might already have this created, but let's go to Dynamo and let's look at the tables available. So we can see I did create one earlier, but let me just show you how you would create a table in Dynamo DB. To create a table in Dynamo DB, it's basically like a Python dictionary, but it can scale automatically. So we'll just call this hello. And then the only thing you really need to do is make sure you have some kind of unique ID, because it, just like a dictionary, it needs to be a unique identifier. So we'll just say globally unique ID. That's the common convention. And if I put this in here, it takes a second. And I think, again, the easiest way to conceptualize what DynamoDB is just imagine it's like a Python dictionary that can scale automatically and hold like basically any amount of data you want. To go use this hello thing, I just go here and I just go, Apple, right, and it puts in a unique name in there. I can make another one, call this banana. I don't even know how you spell banana, but I'm not known for my spelling. There we go. You can see how you can really easily use this. And then if I want to delete stuff, I can delete it. I can export stuff to CSV. It's a great automatic tool that lets you create databases just literally in seconds. So I already created one. Yep. it can hold. You can put other things. So you can put in integers as well. Like you can put strings, binary numbers. Like yeah. So it's basically just like a very flexible schemaless database that many people use to build entire companies on. So instead of you having to do all kinds of complex stuff in SQL, you could just use this, start clicking buttons, creating stuff, and create a schemaless database, which is what I do a lot. So this database here, thing I already created, I just put a few names of companies in here. So this will be where I hold my work. So what happens is that this thing is going to call into the producer Lambda that I'm creating is going to read Dynamo DB and find out what names I have in here. For this example, it's just 5, but it could be 5,000 or it could be 50,000, right? You could use Dynamo as like a lookup table, and that's where I find it to be pretty useful. So we have these company names. Sure. You can do bulk updates as well. So you can upload data automatically from S3. There's workloads. You can also create triggers, and the triggers can put data into here. Um, I don't I don't know if you can do from the user interface. I don't know if there's a way to do this, but for sure there are ways to upload large quantities of data. You also can programmatically upload data using Boto 3. But I, yeah, but there, okay. But for this kind of stuff, it's really great for demoing things because and just building stuff really quickly. People do use this in production and run entire companies using Dynamo, and that's it. The other competitor to Dynamo would be MongoDB, which I think they might have. I don't know if they have a Mongo um, solution necessarily, other than this. I think that Dynamo now is Mongo compatible. I think that's the big thing about it. But I've found DynamoDB to be a pretty good tool for building things. So let's go to this next. So we set up this. So we have a DynamoDB table, and we also have this queue. And so the other thing to point out here that I don't know if I've gone into that much, but I will just reiterate this is that once you start building production systems, if you don't create logging, you're not doing a good job. So that's another thing to remind yourself of is like any distributed system must have logging in a production environment. Just period. You have to have logging so that you understand what's happening when it's running. Uh, Otherwise, you just won't be able to debug it. So you can see here how you would set that up, and you can see I put little statements here like, and you can turn some things at different levels so they don't log as much or log more by doing these levels. So logging libraries have debug, info, warning, and error. Those are typically the levels, and so you could tell your logger that in one environment to um, always log the debug messages. So if I wanted this to not show up in production, I could change this, for example, to debug, right? But for now, we'll just leave it at info level. This will just show me the table that I'm scanning. And this first line of code here just grabs everything from DynamoDB and puts it into this items variable. This next one, what this does is it sends a message into SQS. So this basically takes whatever I decide to put in there and puts it into SQS. And then this kind of orchestrates everything. So it scans the table and puts it into Dynamo. And then the handler is pretty simple. Like all I have to do is this one line of code because I use these other two functions. I grab the data from Dynamo and I inject it in. So the only thing I need to do here is I think by default, Boto 3 is installed. With Lambda, you don't even have to install it. So I believe I can just right click on this and deploy it. And let's see if this works. And then I will go here and go to Lambda. And the way we'll know this thing works, here we go. Here's that Lambda. No, that's not the Lambda function, or is it? Last modified producer March. No, that's an old one. No, that's today. That's weird. That's weird how it showed up that quick. Okay, so this thing looks like it's ready. Here you can see the code transferred from this function, right? This deployed it. Now, a couple things to remember is if I scroll down here, you want to double check that this role is set. So because we already set it, it will be fine. And then the other one is the trigger, right? So we talked about this before, but this is not going to do anything unless I set up a trigger. And so the trigger that I'm going to set up is going to be a CloudWatch timer. So I'm going to go to CloudWatch events here. And inside of here, I'm going to create, first I'm going to look at an existing rule. We can see what it looks like. So I'm going to create a new rule so you can see how that works. If I say 1 minute, contains only numbers. So one minute, March 21. So I'm going to create a rule that basically says every minute call this Lambda function for me, and just this calls a Lambda function every minute. Now, in a real like data engineering pipeline that you're building from scratch, you would never often want to do something every minute. It would just be, it could be very expensive, right? You could actually cost the company a lot of money because you're running something all the time when maybe it only needs to run once a day or once an hour. When you're prototyping, 1 minute is great because it allows you to quickly get feedback. So we'll go through here. I'll put this rate 1 minute. Again, you could say rate one time a day or one time a month, and also make sure this is triggered. Once I do this, then this what'll happen if we don't have any bugs, which I'm not sure if I'm never confident the first time I do something, but if we didn't have any bugs in our code, this we'll see that it was invoked, and it'll be invoked automatically from the CloudWatch timer. So I think we just need to wait 30 seconds or so, and it'll be invoked. And another thing that'll happen is that currently this has 0 messages. Oh, whoa, that was quick. That's a lot of messages. I'm not sure why it's pumping that many messages in there. But if I look at this producer and I look at view messages, there we go. Look, you can see all these. So this thing's cranking. This thing's running, and so now it's putting all of these messages into SQS. And so you can imagine how useful something like this is, because you're able to use it to put work into a queue that later another Lambda can process. So again, let's look at what we set up. We set up this. So this triggers Lambda. This runs at an interval. The Lambda itself, once it's triggered, it reads data from Dynamo DB. And again, whatever data we put in there, we just put 5 companies. It could be 50,000 companies. It could be whatever you want to put in there. Then it takes that data and it shoves it into SQS. And why do we want SQS? There's 2 real strong components of SQS. One is that SQS, you can't break it, right? Like it's literally indestructible. No matter how many messages you put into it, it will accept it, and it will store those messages. And the second nice thing about SQS is that it'll directly fire a Lambda function. It's a 1-to-1. So basically, you get incredible concurrency, and you get it for free, and it's event driven. So as soon as a message comes in here, boom, a consumer Lambda will populate. So that's what we're going to build next. And this consumer Lambda will call AWS comprehend, and then it will store the results of our machine learning pipeline into S3. So next thing that I'm going to do is I need to grab that next code. So you can see here, look, this is all working as expected. And we're going to create and now we're going to need to pull that data from there. So I think I have that inside of this repo somewhere. Let's see. it's going to be, let's go put this here. I think it's going to be serverless sentiment. Yeah, this one. So let's grab this, all this code, and let's go back to our Lambda environment here, and let's make another one. So we'll call this consumer, because this is going to consume the things that are in S3. Okay, that looks good. And we'll say consumer March 21. And we'll say Python 3.6. There we go. No trigger. Now this again is how easy place to make a mistake, because if you don't give it the right role, it won't have the privileges to talk to the other things in AWS. So we're going to go to this one that we had set up earlier. There we go. So now we've got the consumer, and I'm just going to paste this code in that was in that repo, and then I'll walk through what it does. So this is slightly more complex for a couple reasons. One is that it uses two third-party libraries. It uses pandas and it uses Wikipedia. So we need to make sure that we install those libraries. And there's a couple different ways to do it. I'm going to show you kind of an easier way to do it. A more sophisticated way would be to package it together with Terraform or something like that. But for here, we're going to yeah, again, import those libraries. But before I do that, let me just walk through the code. So again, I set up logging. All this does is just returns an SQS connection. And then there's some code here that can count the messages in SQS. If I don't even need this for now, but if I needed to count messages to do something, I could. Now, this is an important thing to remember about SQS, is that you have to tell it to delete the message when you're done. That's the only thing you really have to do with SQS is once you've consumed the message, you have to delete it so that it knows that you've processed the message. Otherwise, the messages will stay there and the queue will infinitely grow forever. So this is the code that does that. And then all this stuff does is just take the names that are in Wikipedia, the names that are in the Dynamo DB database, and it uses this library called Wikipedia to grab a snippet of Wikipedia. And then I take that snippet of code that has all the text in it, and then I do the sentiment analysis on it using the comprehend library, which again, hopefully it works. And then I apply that sentiment, and then I write the sentiment to S3. So again, this really probably common workflow that someone could create to do sentiment analysis on AWS. And then here's the Lambda function that goes through here and runs all that code. And you can say what it does is it grabs the Wikipedia entry, applies sentiment analysis, and then writes it to S3. So a lot of stuff going on, and it's only a couple hundred lines of code. So to get started here, what I'll need to do is I'm going to source the virtual environment that it creates for me. So look at this. This is kind of interesting. Look, it creates a virtual environment for me right here. See that? So what I'm going to do is I'm going to source it. I'm going to cd into serverless, cd into consumer here. And then I'm going to cd into here. So I'm now in the Lambda function, and I'll source that virtual environment. Bin activate. Wait, source b and bin activate. Okay, so I've got this environment to play around with, and this is the part that's a little bit weird about how they want you to do this. But what I'll do is I'm going to do an installation, and you can see it. It looks like this. Where is this installation process? See this pip3 install Boto. So I'm going to install this like this. So we didn't have to install Boto 3. I think it already comes by default. But to install packages, you put it at the directory above where the Lambda code is, right? So in this case, this is the application, and then the Lambda function itself was called this. So you put it at a directory right above. And so we installed that. Now I'm going to install the logging library code. There we go. And then I think the other one I'm going to install is, let's see what else we got, Wikipedia and Pandas. So I'm going to do this. I'm going to say Wikipedia, and then Pandas. Okay. All right, so those are ready. Now, and once these are ready, I can just deploy it because this code's already been something I've used before. So that looks good. You can see all these libraries are one level above. Okay. Let's see, target directory already exists. That's fine. So let's right click on the consumer here and let's deploy this. And this should show up inside of Lambda. And while this is actually populating, let me just show you this queue is going to be much bigger now, right? Because it's running every 1 minute. So look, you can see it keeps getting bigger. It keeps getting more and more messages populated in there. Okay, here's the next function here. And so this thing is pretty much ready to go. Look, it even it put all that into like a zip file. So that's another, you can actually zip all this stuff together and upload it as well. But if you have a lot of third-party code here, it won't show up, so you can't edit it. This is just more of an FYI. You can see the existing role set up here. So the only other thing we need to do, again, remember we have to set up the trigger because it's not going to do anything until the trigger set up. So we're going to click on this trigger and we're going to need to go to SQS. There we go. And from here, we now need to put in the name of the queue. And we know there's only one queue. It's going to be this one. And then this allows you to specify how many messages to pull out at once. Let's just leave it by the default. It'll pull 10 messages out at once. Now, as soon as I click this, the queue is going to be drained really quick because this is completely asynchronous. So if I click on this, we go back to SQS. This should be almost instantaneously, this, unless there's a bug, which is very common. This should, let's see here. We may have a bug though. No, let's see, is it draining? Let's see how quickly this drains. It looking promising. We could see messages in flight. It looks like it's processing the whole queue. Yeah, so it looks like it is working, right? So we can see this is, so there's nothing left. There's only messages that are currently being processed. And you can see it's just crunching through all those messages. So what's happening, if I go back here, is we can look at this, the logs here and the monitoring, and we should see this thing's invoked a ton of times. That we can see, if I look at the last hour, that this is again the consumer. This should be, it may take a second for this to populate, but we could look at the logs and we could see that this thing is probably getting called a ton of times. Yeah, here we go. Look, here's all the messages. This thing is getting called a bunch of times. And so if we go now to the target location, we know that from our code here, the very last thing that this does is after it applies a sentiment analysis, it goes into a bucket called Fang sentiment, and it puts the results of that into the bucket in S3. So I can go to S3 here and click on here, S3, and this should give us the ability to see what it put in here. Here's an example. And look, I might have a small bug here. I don't know why it's doing that. yeah. So, I mean, I guess it's okay. It's not. But let me download this and let's see what's inside of here. I mean, I could probably make the name look somewhat neater, but I could actually go to, yeah. So if you see this, you can see, look, that it grabbed inside of here the name Wikipedia, and it found the sentiment to be neutral for that company. So we have a full end-to-end pipeline. Again, let's just show what the picture is that it's doing. It is this. It's This is called every minute. This reads data from Dynamo DB. This takes the messages, puts them into here, and then this consumer does this whole machine learning or AI operation on whatever it is. In this case, I'm doing sentiment analysis. We could do transcribe stuff. We could do computer vision. I mean, whatever it is you want to put, you could put something similar. Now, let me just show you one last thing, which is that if we go to Dynamo DB, so let's just first look in here. Look, you can see that it's got yeah, I might have some kind of a naming bug to fix out, but basically we can see that these are the companies, right? So what if I want to put some other companies inside of there? What I could do is I could go to Dynamo DB, and because now this thing is alive, right? It's a living system, and it will process anything I want. I could go into this, and I could go to my table, and I can just change my table to do anything I want. So let's see what's in here. Did I have? Oh yeah. So we see we work, Netflix, Google, Facebook. Well, why don't I add another company? Actually, let's see here. We could put what's another? I guess if I went to Wikipedia, I could look for maybe Oracle. Would that be a good company? Let's look at Oracle. Would that be confusing? Oh no, Oracle. Let's see. Let's do a different tech company. How about Pinterest or something? That's probably not going to be confused. Okay, yeah. So this one, let's throw Pinterest in there. So I'm going to go back to my DynamoDB database. Where's this DynamoDB database? There we go. And let's just put in a new company, Pinterest. And then again, this should be real time. It'll just grab the data, put it through the pipeline. And then if I look at SQS, this won't even, look, it processes it so quick, it's literally instantaneous. If I go to S3 and I refresh this, you should see that Pinterest should pop up here quickly, unless it's got some kind of a problem populating Pinterest. But in a nutshell, that's the power of something like this, is that once you've got it hooked up, then it really is like the pipes in your house, right? You have water, you have sewage, you create this pipeline. Now you can dynamically put new data in, and maybe even you have another Lambda function feeding this in with lots of messages. And then at the same time, you also could have another thing connected to this that maybe takes the sentiment analysis and then maybe it puts it into a mobile app, or it does some other thing to it. But in general, that's the real power of something like this, is just the speed you can develop it, and then also how it's now dynamically, moving back and forth. So that's probably a good bit. We can probably stop.